And this is about syllabus. See, as in the name, it is analog and digital electronics. Analog electronics also you are going to study, digital electronics also you are going to study. In part A, you will be studying analog electronics. Okay, this is a laboratory. In part A, you will study analog electronics experiments. And in part B, you will be studying digital electronic experiments. So there are 9 experiments. 3 experiments belongs to analog electronics and remaining 6 experiments belongs to digital electronics. Okay. So for your theory subject, this is the prescribed textbook. For the entire subject, you will be studying only this textbook. Okay, this will be available in library. Please do take the textbook. And these are the reference books. If it is needed, you can reference, but most of the things would be covered by this textbook itself. And this is about theory syllabus. In module 1, you will be studying theory concepts related to analog electronics. Okay, only module 1 is related to analog electronics. Rest of the modules, module 2, module 3, module 4 and module 5, all these things are related to digital electronics. Okay, so we will be starting the subject with module 2 itself. After completing digital electronics, we will be, in the last, we will be covering module 1, that is analog electronics. Okay. Okay, now the presentation is visible. Whether the presentation is visible? Okay. Okay. So whatever I told, I will tell once again. So this is analog and digital electronics introduction class. So I just told you about the subject code for theory, analog and digital electronics 18 CS33, for analog and digital electronics laboratory 18 CSL 37 is the subject code. Okay, 18 CSL 37. And laboratory experiments are divided into part A and part B. So you can observe it's given part A is related to analog electronic circuits. Part B is related to digital electronic circuits. So part A, you have 3 experiments which is related to analog electronics. And part B, you have 6 experiments. Okay. And for your theory, the textbook is Charles H. Roth and Larry L. Kinney. This textbook covers entire syllabus. You need not have to refer any textbook for your internals or exam. Definitely for the sake of knowledge, you can refer the reference books. Okay. And as I said, there are 5 modules. In the first module, analog circuits are covered. And in remaining 4 modules, module 2, module 3, module 4 and module 5. In these modules, digital electronics are covered. Okay. So majority of So we will start with module 2. Okay. And after completing digital electronics part, we will come to module 1. Okay. So question paper pattern. The question paper will have 10 questions. You would be aware because you wrote first semester exam already. There will be 2 questions from each module. Each question will have excuse me, each questions will have questions covering all the topics under module. So you have to choose 5 full questions, 1 full question from each module. Okay. Till now, if you have any doubts, you can ask me through chat window. I assume no doubts. I didn't tell anything. I just told about subject code. I just told how many experiments are there, how many topics belongs to digital electronics, how many topics belongs to analog electronics. That's all I told. So now you people have to take pen and paper or some notebook. Okay. We will be starting with the some technical stuff. Okay. So students, I hope followed all the things till now. On the screen, you can observe 2 types of clocks, isn't it? This clock we call as analog clock, and this clock we call as digital clock. So what is the difference between this analog clock and digital clock? Can someone put it in the chat window? What is the difference between analog clock and this digital clock? Any one difference? Shoaib Syed, are you there? Can you type in the chat window what is the difference between analog clock and digital clock? So I will not consider your attendance for today's class. Are you listening? Okay, Parvati Saler, can you type in the chat window what is the difference between analog clock and digital clock? Are you people there or not?
Yes, ma'am.
You can even tell yourself and tell what is the difference between analog clock and digital clock. If you are not comfortable talking, you can type in the chat window.
Ma'am, analog clock just displays the time by the hands of the clock moving, whereas digital clock just displays it with graduations.
Okay, okay. Okay, as she said, getting the time by observing the hands of the clock. Always the accuracy is less in analog clock. You cannot tell second, millisecond accurately. But in digital clock, always the accuracy is more because it is clearly mentioning what exactly is the time. So let us have some okay. We have listed in the form of advantages and disadvantages. Okay, when it comes to analog circuits, they are expensive. No privacy is preserved because no cryptography or encryption related to this, and you cannot merge different data. It's little bit tough. Okay, and there is no error correction capability. You may not be understanding all these things. You just have to compare and understand how digital circuits are better, in what way analog circuits are better. Okay, and advantages are smaller bandwidth, okay, here in digital circuits it is inexpensive, privacy is preserved, and it can merge different data, error correction is there. And disadvantages of digital circuits, you have to use larger bandwidth. You will understand why you have to use larger bandwidth shortly. And synchronization problem is relatively difficult. Okay, so synchronization is difficult and larger bandwidth, that is the disadvantage of digital circuits. And similarly, advantages of analog circuit is smaller bandwidth and synchronization problem is relatively easier. Okay, so advantages of digital circuits, it is quite inexpensive. merge multiple data. Similarly, disadvantages of analog circuits, it is expensive, no privacy preserved, you cannot merge different data, and error correction is having less capability, whereas in digital circuits, the error correction is having higher capability. It's not in your syllabus right now, but just for the general understanding, you have to know this. Okay, so you might have, like whenever I'm talking to you, the voice is analog or digital? It is analog voice. But the when it is reaching you, it is getting it is transmitting as analog and then it is getting converted in digital. So there is variety of places wherein you are converting analog signals into digital signals, digital signals into analog signals. So it is very important for us to know how exactly this conversion process will happen. Okay, so just for the general understanding, you have to know how exactly the conversion happens. Okay. Okay, look at this slide. Look at this slide. This is analog signal. You can observe here it is sinusoidal analog signal. Okay. And here you can see this is digital signal. You can fairly accurately tell this is 1, this is 0. This is 1, this is 0 like that. But in analog signal there is continuous variation. Continuous variation means here the value of the signal is different. Here the value of signal is different. Here the value of signal is different. Here the value of signal is different. So when I am telling value of the signal, you can think. So here it is having different height, here it is having different height, here it is having different height. That is the definition of analog signal. But in digital signal, what is happening? It is either high or it is low. The height of the signal as amplitude, either it will be high or it will be low. So just for the sake of completion, let us discuss how exactly these analog signals are getting converted into digital signals. So if you have, I had asked you to take the paper and pen, right? There in your notebook, you can, okay, whichever the wave I am pointing using mouse, that particular wave you can write. Okay. Now, what is my intention? I want to convert this analog signal into digital signal. So what I would do? I am partitioning this analog signal with certain distance. I am calling this distance as TS. Okay. So I am having one partition, two partition, three partition, 4, 5, 6 and 7 partitions are there. Write the analog signal. Its minimum height is 2 and its maximum height is 10. It's written here. Its minimum height is 2 and maximum height is 10. And after that, you are partitioning it. This process of partitioning it is called as sampling. The process of partitioning it is called as sampling. Okay. Are you people following whatever I told? Can you reply in the chat window if you are following, or if you have any problem, you can let me know in the chat window. I assume everything is going on well, and let me continue. So this is our analog signal. You have sampled it. Sampling means you are dividing it. Okay. After dividing it, what we are doing, this is very important. In the previous slide, we wrote like sampled using vertical lines. In the next step, what I'm doing is I'm putting horizontal lines. You can observe here the red lines Okay, the red lines are there here. You have sampled it. How means you are, this process is called as quantization. Okay, this process is known as quantization. There are four red lines. Identifying the points. You are identifying the points. Okay, if your analog wave crosses this red line, that means the value is 0 0. Your analog wave crosses this line, that means your value is 0 1. If the analog wave crosses this red line, then it is 1 0. If the analog wave crosses this particular point, then it is 1 1. So why is the values 0 0 for 0, 1